Enthalpy is the topic of this video. I've been telling you in the last couple of videos when we were looking at the steam tables that we would go over enthalpy, and here is where we will talk about it. When we go through and we derive our equations, there is going to be this sum that frequently appears in the equations. This is internal energy plus pressure times volume. And it appears in there so much that we're going to have a term for this sum, and that is going to be enthalpy. Okay, so when we're talking about enthalpy, this is essentially the equation. Now, the symbol for this is going to be capital H. Now, we also have a specific enthalpy. The symbol for that is a little h. So think about the internal energy. Regular internal energy is a capital U. Specific internal energy is a little u. Same thing here. Capital H is just regular enthalpy. Little h, specific enthalpy. Now, our equation for specific enthalpy, you can probably guess, is specific internal energy plus pressure times specific volume. And then we can circle that. Now, the units for specific enthalpy are going to be kilojoules per kilogram. And then for regular enthalpy, we would just have kilojoules. We typically are going to be looking at specific enthalpy though. Now, we can find the specific internal energy and specific enthalpy values in the tables. And just like with specific volume, we have an equation that we can use to figure out what the exact values of U and H are if we have a liquid vapor mixture. And those are going to be very similar to what we did for specific volume. So U is going to be equal to 1 minus X, or X is quality, times UF plus XUG. Then if we write this out, expand it, we're going to have UF plus X, UG minus UF. This is our equation right here that we're going to use for specific internal energy. Now for enthalpy, we have one that is essentially the same. We're just going to switch it out. Instead of U, we'll have H. So we'll have 1 minus X, HF plus X, HG. And that's equivalent to HF plus X times HG minus HF. So let's box these because you will need these quite a bit. Just like we needed the one for specific volume. Now, if we look at the table, let's come over here real quick. So this is the saturated water table. And if we look in here for enthalpy, here are the enthalpy values right here. Notice we've got HF, so this is the enthalpy at that saturated liquid point. We also have HG, that's the enthalpy value at saturated vapor at that point. So at the point G on the vapor dome. And then in the middle, we've got this HFG. And this is saying evaporation here. So this term right here, what this is HFG, you can use that because that is essentially this difference right here. So HG minus HF is HFG in the tables. All right. Or at least it is in this textbook. Okay. Your textbook might be a little different, but this one, that's what it's got. All right. So these are going to be our main equations that we will use. And now let's talk about something called specific heat. Specific heat, what this is this is going to be the amount of heat that is required to raise the temperature of a unit mass of a substance up 1 degree. That's what it is. Now, since specific heat, it says a unit mass of a substance, it's going to change depending on your substance. All right, but that's what specific heat is. You have your substance, you want to raise that temperature up by 1 degree. How much heat do we need to make that happen? That's the information specific heat gives us. Now we're going to have two different versions of this. First one is going to be C sub V, and I'll tell you what this V means in just a second. That's going to equal the partial of internal energy with, or the partial derivative of internal energy with respect to temperature, and then we're going to put a V here. All right. What this is this is saying this is the specific heat of constant volume. Basically what you're going to do is you're going to raise that temperature up 1 degree, but while you're doing that, you are going to hold the volume constant. So you're not going to be able to expand or anything else. Volume will stay the same. And this is our equation for that. And this V here, just remember volume's held fixed. Now there's another one, which is Cp. It is going to be the partial of specific enthalpy with respect to temperature. And then we'll put a P here. So you can probably guess what this means. This is our specific heat of constant pressure. In this instance, we're going to raise up the temperature 1 degree, but now we're going to hold the pressure constant. So this P, let's just say pressure is held fixed. Now these terms are going to be found in the tables. All right. Or they'll be given to you, okay, because they're going to change depending on your substance. So you're going to find those in the table. So now if you look in the back of the book at table A19, you'll see we've got a list of substances, and then we've got specific heat. It gives you Cp, that's the one it gives you, specific heat at constant pressure. Later on I'll give you an equation that relates these two, or Cp to Cv, so you'll have the equation for both. All right, so here would be the Cp values for the different substances. Now our units that we're going to have for this, we're going to have kilojoules per kilogram Kelvin, or sometimes you'll have kilojoules per kilomole Kelvin. This would be the SI system. In the English system, you're going to have BTU per pound degree Rankine, or you'll have BTU per pound mole degree Rankine. So those will be your units. There's also something called a specific heat ratio, and that ratio, the symbol for it is K. Some books have a symbol of gamma, so if you do aerodynamics, you'll see gamma a lot of the times. All right, but K and gamma, same thing. The ratio is going to be Cp over Cv. Okay, so just keep that in mind. So it gives you, if you're given the ratio value and you know Cp, you can find Cv, for example. Now, an important thing to note here, there is no relationship between specific heat and Q. A lot of people ask that, but there is no real relationship between those two. Q, remember, is the energy transferred in by heat. This specific heat information we just talked about is something different. Right? This one is just based on the substance and how much heat is required to raise the temperature of that specific substance. All right, let's stop this video there and we'll pick it up next time. Thanks.